Alright, solving logarithmic equations. This is the last video of the night. Let's see if we can get something cool out of this. So here's our problem. Maybe you already kind of know how to do these and you're just using this to practice. So go ahead and practice it, start the problem and see if you can come up with what I have. So in this case, this is a common logarithm equation. There's no base. That's the reason I know it. So we know the base here is 10. So there's a couple ways you could think of doing this. The inverse of a logarithm base 10 is take the logarithm to that power, or take 10 to that logarithm's power. Or you could just convert this to an exponential equation, which is what I'm going to do. So 10 to the third power is equal to 3x minus 5. So 10 to the third equals 3x minus 5. Okay, so that pretty much demolishes the problem very quickly. So now we have 1000 equals 3x minus 5, which makes that 5 somewhat insignificant. And then you keep going from there. So plus 5, plus 5. So 1005 equals 3x. Then you divide by 3. And so x is equal to 1005 divided by 3, whatever that number is. And so that's essentially what you do. So that's a simple one. But you want to get whatever equation you have, try to get it to one logarithm and then convert it to an exponent. It generally makes them disappear quickly, the logarithm part of it. It makes them pretty simple. So let's look at something else. So you look at this next problem. This was a little more complicated. Log 2x minus log x minus 3 equals 1. But if you remember, we had those three properties of logarithms, which are kind of important to remember and keep in mind when you do these. The first, I'll do it with the natural log, but it doesn't matter. Natural log plus natural log of y. Remember, you can combine them and multiply. Combine them to one logarithm. And multiply. For subtraction, the second rule, if you subtract two logarithms, remember you can combine those into one logarithm and divide your two numbers. And so notice that's the situation we have here. We have two logs subtracting from each other. So here we go. So we'll use that second rule and combine the logarithms into one. So when you do this then, and again, this is a base 10 logarithm. So when you do this, log 2 to the x minus log x minus 3 equals 1, you combine it this way. So log 2x over x minus 3, and then equals 1. So, I mean, that's it. And remember, common log has a base 10 there. And so now when you convert that to an exponent, 10 to the first power equals 2x over x minus 3. And we can solve this pretty quickly now. 10 to the first is just 10. This is really 10 over 1 equals 2x over x minus 3. We need a common denominator of x minus 3, which you could also call this cross multiplying, but be careful there. So I'm going to take this side times x minus 3 on the top and x minus 3 on the bottom. And so we would have this. 10x minus 30 over x minus 3 equals 2x over x minus 3. Then the denominator crosses out. I mean, that's the rule everybody learns, but really what's happening is we're going to multiply by the denominator to make it cross out. So x minus 3 distributed through this would cross this out and this out. You got to do it to both sides of the equation, excuse me. So this would also be times x minus 3. So this side and this side would also cross out. Whatever you do to the left side, you got to do the right side. And so you have 10x minus 30 equals 2x. And then you keep solving, get your variables on the left, numbers on the right, I'm going to do it all kind of in one step. And so 8x equals 30. And so x is equal to 30/8. And we could should reduce that. I apologize. 15 for us if you take 2 out of that thing. And there's your solution to that logarithm. So we've slayed that one. So let's try one more. Okay, this one looks kind of nasty. Not gonna lie. So we've got natural log of 3x plus 8 equals natural log of 2x plus 2 plus natural log of x minus 1. So at this point, it'd be a good idea to maybe stop the video and see if you can do it. Maybe you can. Maybe you're that good, and that'd be wonderful. So what we're going to do first here, and there's multiple ways of solving any math problem, but I'm just going to give you one, maybe two methods to do this. First thing is with logarithmic equations, try to get one logarithm on the left and one logarithm on the right. So combine it down, simplify each expression. That's why we did all those expression practice before these. So on the right side, natural log of 2x plus 2 plus natural log of x minus 1, you're adding two logs, so you can combine that to one logarithm and multiply. So that is the natural log 2x plus 2 times x minus 1 equals. And on the left, it's already one logarithm. Okay? Now, there's two ways to look at this to get rid of your natural logarithms, but let's just deal with one. You could convert the natural log to log base e and then convert it to an exponent, and everything kind of cancels out. But the inverse of a natural log is e to that power. So if you take both sides of the equation, e, to the power of this, whatever you do to the left, you do to the right, so e to the power of this. What happens is your natural log and your e's are inverses. They end up simplifying out. And so you're left with 3x plus 8 equals 2x plus 2 times x minus 1. So, and now we can go ahead and simplify that. I'm guessing we're going to end up with a quadratic that we have to use the formula for. It won't factor nicely because I think I changed it a little bit. So that's 2x equals 2x squared. I'm distributing minus 2x plus 2x minus 2. And again, how I got that right side, just to kind of recap, I used distribution, distributed the 2x through both, then distributed the 2 through both. And so just nothing's fancy there, just distribution. Then you want to combine. I'm going to move everything to one side of the equation on the right. Minus 2x plus 2x, those cancel out. That's kind of nice. And so then I'm going to subtract 3x and subtract 8 from both sides of the equation. And so we'd have 0 equals 2x squared minus 3x minus 8, 9, 10. And I'm kind of lazy. I don't want to guess and check a factoring and see if that thing factors. I'm assuming it doesn't. We could use the discriminant and find out, but let's just jump right in and not waste any more time. So to solve this equation, you got to use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, because this is a quadratic. So x equals 3. If you don't know how to use the quadratic, it'd be a good idea to go watch another video on how to use that thing. B squared, b is negative 3, so negative 3 squared is 9, minus 4 times 2a, and c is negative 10, all divided by 2a, which would be 4, because 2 times 2 is 4. So x equals 3 plus or minus the square root of 9 plus 80. Yes, it does not come out very nice at all. And so my two answers would be x is equal to 3 plus the square root of 89. And 89 is prime. Nice. and x equals 3 minus the square root of 89. What a lovely number. And so those are our two solutions to that original logarithm. Wow, that's cool. So, hope this helps. You could, if you're feeling daring, you go plug that baby in. What might be better is to give the GeoGebra a try again and see if the graphics, where the two graphs meet, or use Wolfram Alpha. I just want to let's do Wolfram Alpha again, just because that's so cool. So I'm going to hit stop for a second and pull up Wolfram. Okay, so in the search engine here, I'm going to go ahead and type in that equation. You can see them both. So the natural log of 3x plus 8. And maybe I made a mistake and it's going to be wrong. So kind of the drum roll, I'm hearing to the drum roll at this very second. Plus the natural log of x minus 1. Enter. Hopefully I typed it in right. It looks like I did. It's thinking about it. Shows you how slow my internet's running at midnight, 11:22. And it looks like it's done. And so here we go. Ooh. Ah, there they go. There's what your two graphs look like and where they meet. That's kind of cool. And let me see if I can get that to pop up the point. Yep, there's your point. 3.108 is the approximation. Aha, that's so exciting. There it is. So 1/4 3 plus the root of 89. Now, notice I had plus or minus, so I was technically wrong. One of those does not work. And I should have known that. I just wasn't paying a whole lot of attention. I was sleeping. So the negative does not work. And 3 minus square root of 89 divided by 4. Let me pull that up one more time. I wanted to double check that. Yeah, and I should have mentioned that. This one here we have to get rid of. Well, thanks, Wolfram. Thanks for helping me out. It's a great app. Not that I'm an advertiser for Wolfram. I'm not I don't use it very often. I'm kind of new to it, but it does make a really nice app for your phone. I think it's $3.99 or something. I don't know. A lot of my kids have it. They love it. But x equals 3 plus root 89 over 4. Well, the reason this one on the bottom doesn't work is you cannot you don't have real solutions when you do negative. So I don't want to plug this thing in. It's too nasty. Let's just plug in natural log of -5. When you plug that in, that's not, you're going to end up with an imaginary number. So not real. It's not going to be a real solution. And so we'll leave it at that. But so your only solution there is x equals 3 plus the root of 89 over 4. And so that was kind of cool. I'm glad I plugged it into Wolfram. Kind of a neat program. I'm more impressed with that thing every day. So best of luck. See you next time.